we learned about what it means for your design to satisfy the design criterion of modularity. And just to review, you have to divide, you have to specify, and you have to concurd. So these are the three important phases that you must satisfy in order to have modularity. And once you have a modular design, it's guaranteed your design is going to be maintainable, extensible, and also reusable. Just make sure you understand these concepts before you move on. So now let's talk about another important concept over here called abstract data types. Back in your 2011 data structure course, you may have learned it in as a more mathematical and algebraic specification of your module. But for this course, since we're dealing with object orientation, so I'm going to modify that definition just a little bit just to be narrower, to be more fit into this course. So whenever I talk about abstract data type, what I really meant was it's actually a module that satisfies the modularity criterion. Especially that means each module you have or each class you implement must have a very precise and complete interface. Especially you use precondition, postcondition, and invariance to specify the intention of your module. So that's what I meant. So ADT in this course really means you have a very clear interface using contracts to specify the intended functionality. So that's what I meant by ADT. Okay, let me just go through a little bit more information about what an abstract data type should be. So you should really filter out irrelevant details. So every class that you have shouldn't really include all the information. So you have to think about, for this particular class, what's really its intended purpose. So for example, if you only want to have a utility class, in that case, you shouldn't include, for example, deposit and withdraw, those irrelevant details over there into that particular module. And then it should really consist of a list of declared data and also well-specified operations, right? So every operation, every feature must be well-specified with pre and post condition. And the entire module should always contain invariants for the class. Okay, that's a schematic view for ADT. So from the client's point of view, they can see the interface for your module, right? With for example, if by showing the contract view of your module to them. And then internally, you should maintain some private data structure. It's something called information hiding principle, which we'll show you in a later lecture. Okay. And then, well, again, let's review quickly about the design by contract principle. So what should then be the supplier's obligation? It should be that the supplier should implement all the operations, and also they should choose the right data structure for correctness and efficiency. And for clients, they should really make sure what will be their benefits. They want to make sure the contracts they sign with the supplier is honored. So the client is expecting to get correct output and also efficient performance. And now all the internal details for your ADT should be hidden. That's why usually to show to your clients, you don't have to show them the implementation view. You show them the contract view. I'll have one example for contract view in a moment. Okay, building ADTs for reusability. One of the advantages for having modularity is reusability. The same module can be reused by different contexts. Reusable, and then, for example, you may have in your library classes, you have different modules for you to use. You have stacks, queue, lists, dictionaries, trees, and graphs. Different modules for you to reuse. And once you thoroughly test it, it can be used by, for example, suppliers of other ADTs and also clients of our application. Basically, every time you want to develop your own application or your own module, you do not have to reinvent the wheel. All you have to search through the API for the programming language you're using and see in the library collection, is there anything that you can reuse, so you don't have to build from scratch. Okay. As a supplier, you're obliged to implement the given ADT using other ADT. You should really search for what's the relevant ADTs you can actually use, assuming that all other ADTs you're using, they have a clear interface. Okay, and then design the algorithms to make use of the ADTs. So again, you should have clear interface. And now this is the important point. What I meant by interface is not when you program in Java, having an interface simply means you have a class called interface, and then it contains signatures for the methods only the return type, the name of the method, and also the list of parameters, and that's it. That's not really what I meant by interface over here. What I really meant by was, in addition to the headers of your methods, you should also include contracts for each individual method and also contracts for the class. So that's why we talked about the assignment contracts in the previous lecture. So the interface over here should be way more than method signature. So later on, if you turn in your submission where you're asking to present the interface of your class, if you only include the signature of your feature, that's not acceptable. You should also always think about, which is good for your design, always think about what would be the pre-post conditions and class invariant for your modules. So they really indicate, for the contract, indicate how the clients are supposed to use these methods. For example, for the preconditions, the client would know what should be the input constraints. And also, what are the services provided by the supplier? You can look at the post condition. In a later lecture, we'll talk about what it means for the post condition to be complete. So you can constrain exactly what the supplier should really achieve when they sign a contract with you. And also time complexity sometimes might be also important. Well, I would say as far as this course is concerned, as long as you don't really run into infinite recursion or infinite loops, having a little bit slower speed is actually acceptable, since after all we focus on design rather than implementation. Okay, let's talk very quickly about Java versus IFO, just to see why Java classes, even though they do have interface, but it's not as acceptable as what we meant by interface. Okay, I will show you, I will annotate something here in a moment. But in this particular Java interface, they have so-called generic parameter, which we will discuss later. Having a generic parameter is a very good principle for programming. And then you can actually specify, you can parameterize the type that you may want to use for the members of the collection. Okay, I'll show you how to use it and also the theory behind. We have to review inheritance a little bit in order to do this argument. And also, it's I would say having the Java doc over here is a reasonably intuitive overview of the ADT. However, as we will see, it's not that precise. For example, what's the invariance over here for each list, and what's the and later on we can see what's the pre and post conditions for individual methods. And I will encourage you to actually also look at the Java API. There will be some activities I would suggest beyond the lecture. I will see that at the end. Okay, so methods described in a natural language can be ambiguous, like requirements, as we mentioned before. So now this is just one of the methods in the list class. Let's say we want to set at a particular index some elements, and then we want to return E. Okay, that's just one example methods. And then this is all the information you will get from that particular method. So now I want to argue that it is not exactly the interface that we talk about. It's not really ADT. So let me now go to the Java classes over here. So why are they not abstract data types? So let me put down the answer first of all. Is it abstract data type for Java classes? No, not quite. Okay, so now let's say, okay, we'll talk about this particular list class, and this is your generic parameter. Generic parameter, which we'll talk about in details later how to use it. And now let's say for this particular method called set, it tells you you're going to replace something in a particular position, and then they also say optional operation. If you're completely new to this particular method, you may not necessarily get right away what it really means by optional operation. And then of course they talk about parameters, they talk about return value, they talk about what exception conditions there might be. Again, for example, one of them is the index out of bound exception, to make sure the index you replace must be a valid index. As we said before, this is not exactly precondition, right? It's actually negated precondition. That's what we said in the previous lecture. Now, what's really more severe as a problem over here is when you can read this particular one-line summary, but what I argue is it's not complete, because think about this is the list that we want to update. You have a list, and then let's say we simply say set, I want to set an index I, assuming that it's actually valid. I want to set it to a particular item. It seems like from the informal line of description over here, it tells you I'm gonna go to index I and replace whatever that's there by item. That's fine. Okay. However, I will argue that it's kind of incomplete. It doesn't really say what happens to the rest of the list. For example, over here, you can see the orange region over here. What about that part? If the supplier actually maliciously also updates some part that's not intended in the list, then there's no contracts whatsoever to constrain the supplier not to do it. So that's the problem. So later on, we're going to see as part of the interface for your IFO class, because they support design by contract natively, your post condition not only should tell the clients what should be changed for the operation, but also what should not be changed for the rest of the data structure. So that's something we'll go into. But the final message is Java classes, even for simple cases like a list replacement operation, is not really ADT because you don't see the precise effects about what's going to happen. On the other hand, if we go to IFO, let me show you very quickly, right? In your tutorial video, introductory tutorial videos, you have seen the cross notation already, which corresponds to the for all operation if you use the all keyword here. Now I'm not gonna repeat that over here. What I want to say is, if you now contrast this particular contract view for your IFO classes with the interface view, so-called interface view for Java classes, you can see in IFO, since it's a design language, we tend to it's much more convenient for us to document our modules using contracts. So now you can see for this particular contract view for the classes, we got precondition here with a tag, and then we can specify things over here, so it's not negated. And also we can specify as many post condition as we like, and also as complete as possible. Very clean. We don't have to cache the values of the pre-state value manually. We don't have to. Okay, so that's about the contract view, which you can automatically generate from IFO Studio. But let me say one more thing. There's also the idea about design diagram. Every time you want to generate some good documentation for your customer about your design, you should really include such representation of your classes. For example, array container over here, you will have a selective list of features you want to present to your customer, and also for every feature, you should really include the specification only. Just the specification. It's abstract data type, so you don't have to present the irrelevant implementation details. So that's about the things I would like to highlight between Java interface and also IFO contract view. So now hopefully you can really see why we claim IFO classes with contracts are the true abstract data types with precise information about the interface. Okay, let's go back to the slides and then see what else we have to cover. Okay, we have already seen the IFO classes. You can see the same code over here. And then to make sure, convince yourself that these post conditions here are actually complete. And we will actually argue this more formally in later lecture as a mental exercise for you. Think to yourself what they really mean. Okay. Okay, so we talk about the precise behavior view by presenting the design diagram. So the design diagram itself is an abstraction, which means you don't have to include every feature in your class, only a selective number of features that you think your customer should really understand about your design. Okay, so now beyond this lecture here, I would suggest some activities for you to maybe having some deeper understanding about the modularity versus and also abstract data types that we talk about. So number one, so can you think of more real-life examples of leveraging the power of modularity? Think about it. Just it can be informal. Just find out some example to really convince yourself modularity is not just for 3311. It's actually everywhere. Number two, I will encourage you to actually visit the Java API page. I include a link over here. Just click on that and then try to visit some collection classes, array list, or hash map. The only example I show you in the lecture notes is the set method in the list class. So now go to array list and go to hash map. Try to look at the more complicated operation or method over there, and try to look at the method summary or method detail view, and try to see whether the description, informal description they gave there, is really complete and precise. If they are not, so that means they are not really true ADT. It's just a affirmation about what I said. Okay, that's exactly what I assign you to do. Why they are not ADTs? Whenever you find that there's some ambiguity or incompleteness in the description of the interface for each method or of any method, then it's not true ADT. Okay, and then I want you to contrast whatever methods you choose in the Java collection library with the corresponding features in Eiffel Studio. For example, if you look at some methods in array list, you can find the arrayed list in Eiffel Studio. If you find some methods in hash map, you can find the corresponding feature in hash table. So go to the corresponding method, let's say x. Contrast how x is specified or described in Java versus how x is specified using contracts in Eiffel Studio and Eiffel Library. Are they better specified? My hypothesis would be they are, but I would like you to experiment and experience yourself.